And then after that, actually, I'm going to give a talk on Docker, which I know is one of the most popular topics for tonight. And then Dimitri's going to talk about Mesos, Marathon, Kronos. Anything else?
Also Zookeeper, Eureka, Docker, Spring Boot.
Awesome. So it's an entire evening of just awesome technologies. All right. So yeah, so if this works. So yeah, as I mentioned, a bunch of the distributed system sort of building blocks. A bit about me. So I got my start programming Lisp back in the 80s. Eventually ended up programming in Java, wrote the book Pojos in Action, which was like a long time ago now. 2006 it came out. It is still selling 1 or 2 copies a quarter for some bizarre reason. And then, thanks to this JUG, actually, back in 2006, I heard about this obscure service called EC2 back in the very early days. Was it in this room? Yep. Oh, it was upstairs. Totally blew my mind, just the notion that you could go rent servers for, up to 20 servers for 10 cents an hour, right? And, well, we all know where sort of EC2 went. And along the way, I got so excited, I ultimately created a startup called Cloud Foundry, which was a Java PaaS for EC2 that got acquired by SpringSource right before SpringSource got acquired by VMware. So then I had been there for four and a bit years until about 18 months ago. And now sort of trying to get going on my own thing and building a platform for writing what you could call reactive microservices, just to combine 2 very hot buzzwords into one description. And so some of I got some source code on GitHub. Actually, the second link is basically the code that I'm talking about in the Docker presentation. But I also have the website microservices.io, which is a collection of patterns that can guide you when deciding whether or not to use microservices, and if you do, kind of resolve some of the design issues that you have to address. Just going to leap in. Who was here for the Spring Boot talk or knows about Spring Boot? All right, I'm going to just talk really quickly. So this is an app that I built. So it's a user registration web app. So it puts up a registration form, which then makes a post request to the registration service that stores the registration in MongoDB and actually publishes to RabbitMQ. Just because I think when I created this, I didn't know about Kafka. But so that's kind of the basic app. And what's really cool is it's implemented using Spring, right? So typical sort of Spring controller that's handling the, well, this is the RESTful stuff, right? And then it's using Spring data for Mongo repositories, so you never actually have to write any implementation code. And so that's kind of the Spring side of it. But if you've used Spring, that normally that, well, not only do you have to write that, but you now have to write a whole bunch of configuration, set up a whole bunch of Spring beans, right, in order to make it go. So what's cool about Spring Boot is that you get this convention over configuration concept applied like on steroids, and it basically supplies a whole bunch of default configuration that you can then override. So you hardly have to write any configuration. And it also makes it really easy to externalize kind of configuration properties, like what database to talk to, what message broker to talk to. So you can just do things like set environment variables, which is really, really nice. And then it generates a standalone executable jar with Jetty or Tomcat embedded within it, so you don't have to worry about setting up Tomcat. You just run, java-jar. So it's really cool in sort of the whole microservices architecture where you're constantly having to stand up new mini applications. You know, on a old, I remember projects where I'd set up a whole bunch of stuff and still be using it 2 years later. Whereas, with microservices, you're setting things up much more often. So what it basically does is just supply all this default configuration, and it's actually looking at the class path and saying, well, if you have a database driver on the class path, that probably means that you need a data source and a JDBC transaction manager. Oh, and I also see that you have Hibernate, so I'll set up a Hibernate session factory bean for you. So you end up hardly writing any configuration data. So much so that, like, for the REST service, this was the configuration, where all I had to do was define a rabbit template bean because I needed to customize the JSON mapping because I was using Scala but not instead of Java. And yeah, it's just tiny, tiny amount of configuration. And there's this magic add enable auto config that just makes all the good stuff happen. And the underlying mechanism is that enable auto configuration sucks in a whole bunch of default config, which is then conditionalized. So there's this @conditional annotation in Spring 4. And you can have conditions like, if this class is on the class path, then define these beans, unless I haven't actually defined them myself. So you get a default sort of database config unless you've set up, defined the beans yourself. So, yeah?
I forgot the add conditional annotation. Does it only apply to auto configuration or to init? You remember?
Well, I mean, you have it on a config class or a bean definition, right? And it's just saying whether or not that bean definition exists or not.
Okay, so it doesn't matter whether it's auto configuration or not. So if I don't enable auto configuration for some reason, and I have
well, the default config is actually defines like a whole bunch of config classes that are @conditional, right? And then inside there's @conditional beans inside them, and so maybe not some, I don't know, I'd have to think about, I'm not sure about the auto config, because the scenarios I use it for is sort of like explicit Java config bean definitions.
Okay, so auto configuration doesn't really play any
yeah, I don't know, they might work together. Oh yeah, and then this is the main program. You just kind of Spring application run, config class, pass in the args, and boom, your app just starts up. You can build it with a Gradle plugin or a Maven plugin. And there are these various starter dependencies that just make sure that they pull in the right bits of the Spring ecosystem with a consistent set of jar files. And then you can run it, java-jar, and then you can pass in command line stuff. And then because I included the actuator artifact, I get a whole bunch of like operational URLs like /health, for example. So you just kind of get this production-ready app pretty much out of the box. All right, so then, but that's good, right? So it's a little bit easier. So it's really simple, the fact that you've got this self-contained jar file is good, right? But then it's like, well, which version of Java do you use, right? And then also you might not be using other jar, you might not be using Spring Boot. You could be using other technologies as well, which makes the whole deployment thing kind of difficult. So, you could, I know some people who do this. They actually package their code up as RPMs, right? Sort of standardized packaging format that abstracts the underlying technology. Anyone here do that? No. Because I hear that like SBT lets you just spit out RPMs. I don't know, I've never been a fan of this, right? But what's much better is to like package systems up as AMIs, right? You kind of build a goal, your output of your build process is an AMI that's got everything in it. But and what's also cool about that is you have an AMI, you just use the virtual machine interface to start and stop instances, and it doesn't matter what technology is within that particular AMI. It's sort of abstracted away. But trouble with AMIs is they're kind of slow to build, right? They're slow to build, to boot. They're not portable, and they're really heavyweight. Like, I can only run one virtual machine on my laptop, I think. So that's where Docker comes in, right? Docker is awesome, kind of. So what Docker is this thing you do instead is package your app as a Docker image. And what that is, it's this sort of OS-level virtualization mechanism. So it's incredibly lightweight. So much so that like building a Docker image takes like 5 seconds versus like 5 minutes for an AMI. And Docker basically runs on Linux. But like on my Mac or on Windows, you can download boot to Docker, which basically it uses VirtualBox to boot up a tiny Linux VM with Docker running inside it, but it does all of this magic, and you can barely tell that Docker is not running natively. It's really cool. So if you want to well, I mean, there's just a whole ton of use cases for Docker, and boot to Docker is just like awesome, really is. So one concept in Docker is an image, right? So it's this portable application packaging format, and basically it's a file system image of an operating system and an application. So they're not actually small in the sense that you could have all of Ubuntu in there, right? It's plus the 60 gig jar file. But so, it's kind of like a gig, but because of the structure, the way these things are structured, you mostly are unaware of the size of them. So they actually have a layered structure, so you could think of kind of you have a base image, which is Ubuntu, and then you add your application in it, and that becomes a new layer. And then when you move it around, if the machine you're moving it to, right, already has the base image, it just moves the layer containing your application, which is only 60 meg versus a gigabyte. Yeah.
I personally ran into the following problem. I needed to run ELK stack on Docker.
Yeah.
And both Logstash, Elasticsearch, and Kibana used 3 different base images.
That seriously sucks, doesn't it? Yeah, it's funny, yeah, if you, so it's kind of like you still, at least just once, you have to like download this base image, which could be a gigabyte, and then if you download it to your laptop, and then it gets pulled down into the CI machine, and then it gets pulled down into production, right? But the good thing is, that's just the first time, and after that, you're only ever moving the deltas around. But yeah, if the base images are varying and changing, you notice that Docker isn't, that aspect of Docker is not lightweight.
So yeah, if you're a user, you need to be very picky about the tree of base images that you choose.
Yeah.
I keep running out of disk space on my laptop just because of that.
Oh, is that like a WebSphere problem? Yeah. But so provided that the base images are not changing that often, it ends up being pretty nimble. So like, the stuff I've been doing, like packaging a Spring Boot app, it just takes 5 seconds, and it's basically instantaneous. Okay, so oh yeah.
So are you running your own Docker registry then? Or where are you registering?
Yeah, it's funny. I didn't have any slides on this registry, right? So Docker images either they're sort of running inside your local Docker kind of environment, but you can actually pull them down from a registry. So there's like this globally hosted Docker hub, which is one registry, but you can also set up your own private registry. So there's actually a Docker image that is a registry, and one of the config options is actually to run it, to have the registry storage be S3. So you have a Docker image just running anywhere, and then when you upload to it, it's actually just storing things in an S3 bucket. And what I've been doing, the approach I've taken is actually just running a Docker host, Docker registry on every machine that's all pointing at the same S3 bucket. And I have it running here, I have it running in my CI server, and I have it running in the production environment. And you just access it locally, even though the bits are ultimately going to S3. And I'm just using the standard one, whatever Docker provided. It's kind of, I assume they're still providing it because I kind of installed it months ago, well, about a year ago.
Switched to version 2.0.
Oh.
Different API, so it's more, well, it's rough around the corners, but it works.
Oh, okay, yeah. I'm afraid
But
to
you
up.
have to have 1.6 or newer.
Yeah, I'm afraid to. I'm always afraid to upgrade Docker because, yeah. I mean, I don't want a cascading thing where I upgrade it here, then I have to upgrade CI and then prod. All right, so you got Docker images, so that's what you package your application as. And then there's the actual running container. So you just say, here's an image, run it. And what that does, it just creates a sandboxed set of one or more processes. Usually actually just one process, right? So in the case of a Java application, it's just started, it actually just runs Java. And it's kind of interesting. It's like you've got the whole OS there, but the OS inside the image, but the OS never boots up. You're just, it's almost like the OS is there just to enable you to actually install things like Java, install your application, and also sort of enable the application to run, but all the heavyweight OS stuff just remains on the file system, and no daemons get started or anything like that. And the whole sandboxing is like, what's it like? Well, it's underlying Linux, LXC, control groups, namespaces, and so on. So you can have a bunch of Docker containers, and in each one, you have a Java process that thinks it's listening on port 8080. But each one is running in a different port namespace, and so they're not actually conflicting, which is really quite nice. Oh, and they actually start up super fast, right? Because there's no real booting. You're just launching the Java process or the Node.js process. Yeah, boot to Docker, as I mentioned. That lets you basically run Docker on your Windows machine or on your Mac, and as if it's just, and it's doing it inside a VirtualBox VM, but it's just kind of basically as if it's running locally. It's, it's kind of hard to tell the difference in some ways. It's very good. All right, so packaging Java app, right? So in a way, like if you were to install a Spring Boot app on just any machine, right? You have to install Java, you have to install your app. You have to kind of configure the machine to run Java on startup. And you have to supply external configuration, right? Like telling it which database or message broker to talk to. So the neat thing is, you don't have to do any scripting to install Java because the Docker hub comes with Java images, or images with Java just built into them. So that's kind of cool. And this is the Dockerfile that you use to describe the image that you want to build. So you say, starting from this base image, which in this case is the OpenJDK 8U45, they can't use the Oracle Java because of licensing, which is really annoying. So basically, so you're saying, so Dockerfile always says what the base image is. Maintain is just sort of a comment, really. Yeah, expose says make port 8080 kind of, well, exposed to the outside world in a way. And the command to run when this Docker image starts up is java-jar. And then the final command is to actually the add command that copies the war file into the image. So it's moving it from build / to the current directory, which is probably just /. And that's kind of the Docker file that describes the image, right? And it's a very simple scripting kind of thing, right? It's just execute a bunch of shell commands and copy files around. No chef, no puppet, because you just don't need that stuff anymore. The interesting thing is why does the add command last? Well, you want to. Yeah. So basically, you can actually Docker aggressively caches images. So if you have like the base you got a base image, and then if the command it basically is cached the previous image and the command that you're running against it. And saves the new image away, so you never actually have to recreate, rebuild an image unless the cache has become the command that you're running has changed in some way. So you can actually have quite an elaborate sequence of commands, and if nothing has changed, nothing gets rebuilt, which is really quite nice. And usually, this is the only thing that's changing, right?
Docker recommends to use copy now instead of add.
Oh, yeah? Oh, I have to go read the manual. It keeps changing. I mean, it really keeps changing, right? Doesn't it? Is it just well, I mean, copy sounds better, right? All right. So to actually build an image, you just run docker build -t, which is sort of the tag, the name of the image that you're building, and then dot just says use the Docker file that's in the current directory. And the other scripting stuff is just to copy the jar file out of the Gradle build directory into a subdirectory of the current directory, which I suspect is no longer necessary if you have a more up-to-date.
Yes, as I remember, copy also.
Yeah. Because there's stuff, I mean, basically, it's like the dot gets uploaded to so the image gets built on the server, and so the current directory gets uploaded, and the Docker file can only reference things that are within that directory hierarchy that gets uploaded. But I think there's some other things. I think there's an option to eliminate this.
Actually has an option to point to resources that needs to be pulled.
Oh, yeah?
So you can have your Docker file in source main Docker.
That would be great if I used Maven.
I know. For some reason, I chose to use Maven for this thing.
Oh. Well, the funny thing is, like some of this building stuff I did like so long ago before any of these plugins existed, and I haven't switched. So if anyone knows of a Gradle plugin that actually works, that would be quite good. Okay, then this is how you run it, right? So basically, it's a Docker run command. -d says run this as a daemon as opposed to like run it kind of in foreground mode. -p does port mapping, so it says take port 8. So it's like the host port, container port, and so it's just saying map port 80 on the host to port 80 inside the Docker container. So it's kind of confusing that they're the same. And you can actually specify which network interface to bind to if you want, but by default it just binds to all of them. So that's so the port mapping is how you kind of make ports that are actually off inside a container accessible to the outside world. And then -e is specifying a whole bunch of environment variables, which is really cool because these are just because Spring Boot has this great externalized configuration mechanism, it will just automatically read environment variables and kind of map them to properties inside the Spring application context, which is super useful. You know, -- name gives a name to the container, which confusingly is the same name as the image. Oh, it's a little saying that. All right, so that, you know, and that's kind of it. Oh yeah, and then of course I can, you know, ping it. The thing to remember is that on, you know, when you're running on with boot to Docker, these containers are actually running inside a VirtualBox VM, so they're not actually running on localhost, which can trip you up sometimes. So you actually have to specify the IP address of the virtual of the VM. But there's actually a boot to Docker IP command that actually prints out what the IP address is, and you can assign that to an environment variable.
One thing, development that even better, you cannot build AMI with Java, but at container startup, tell to map jar inside container.
I know, I learned that trick just last week, and I'm going to talk about it now. And then Dimitri is going to talk really quickly about Mesos. All right, so you know, obviously one use for Docker is you just, you know, you hook it up to your build pipeline. Jenkins spits out Docker containers and pushes them into a registry, and then you can just pull them down into your production environment. But Docker is also super useful just for development. It's really, really good. Like, you know, one really great use case, right, is you think about a typical application. You know, not only does it need a database, but it needs a message broker, and maybe it needs Redis, and you know, you end up with this sort of a whole bunch of different infrastructure components that you need to have running locally, just so that you can run integration tests, right? And making sure all of that stuff is installed correctly on every developer's machine in a way that's consistent with CI and consistent with production is a pain in the butt. So it's funny, long time ago, a couple of years ago I think it was, I was using Vagrant to do this, right? Vagrant creates virtual machines that you can have RabbitMQ and Mongo in them. And I've been meaning to write a blog post about it for about 2 years now. But I don't use Vagrant anymore because you can do this with Docker. So you can actually just run, this was my old way of doing it, right? You just type, because the Docker Hub has implementation, or has images containing RabbitMQ and Mongo, you can just type these commands in, and the images will get pulled down from the registry, run, and you've got Rabbit and Mongo running on your laptop, which is like awesome, you know? Especially because I think installing RabbitMQ might be difficult. I mean, I think there's some complexity there. Installing Mongo is not so bad, but now it's just I can have multiple versions, right, as well. So that was sort of the old way I did all of this. But then I discovered Docker Compose, which was, I think, previously called Fig. And have they changed it much, or is it? Well, yeah, but it's.
They keep evolving it, but
okay.
It remains the same idea.
But basically, okay. So basically, you have a Docker Compose YAML file that just sort of defines your system as a set of containers. And then Docker Compose gives you commands to like basically start, stop, and RM, and that the entire system of containers. And what I've got into the habit of doing is, for a given application, defining a Docker Compose YAML file that just creates containers for all of that project's external dependencies. So this is so it's basically, this is the declarative way equivalent of those Docker run commands that I showed previously, right? So I've got a RabbitMQ container that's that image, those ports are mapped, MongoDB container with that image, that port mapping. Oh, and run MongoDB with the -- small files option, because if you don't, then it will complain that the container doesn't have the 3 gigs of disk space that MongoDB apparently requires by default. So that's it. I've declaratively defined my dependencies. And then I just go Docker compose up to say bring up the system, -d to demonize it. And it just goes and creates the containers. And then if I can stop them and I can RM them. And it's really, really convenient.
You can even say Docker compose scale, server's name, and the number of instances. You can just
not in this file.
Not with this file, but yeah.
Yeah, I have not had a requirement for that. I will try it tomorrow.
Also, Chris, Docker compose rm-v. Otherwise, it will keep all volumes in your
yeah, you know,
local file system and get out of space.
Oops. Yeah, it's really funny. I haven't ran out of space yet.
I did it yesterday.
Okay, so and it's just super handy. But wait, there's more. So not only can you use Docker to launch like infrastructure stuff, but you can also use it to launch your application as well. Like you want to bring up the various services in your application along with their infrastructure in order to do end-to-end testing, right? And so, you know, like for a while, I've got a distributed system, and so I was just like, I kind of had a bunch of scripts that just did java-jar, and then I changed it into a bunch of scripts that did docker run-d, right? But what's really cool is you can do it with Docker Compose. And what's really nice, which is what you were getting at, is you do not have to first build a Docker image for each one of the services in your application. You can I wouldn't call it a trick, but you can basically build the image well, it's basically you don't even build an image. It just starts. You're using the base image, and you just on startup you're making the jar file out of the Maven build directory, out of the Gradle build directory or the Maven target directory, just available inside the Docker container. So here it's saying the image is just the regular JDK image, but I'm specifying the working directory as /app. And then I'm doing this volume mapping that's saying take the Maven, the Gradle build libs directory, so that's the directory containing the jar file, and then just map it to the /app directory inside the container. And then the command that I'm running is java-jar /app, name of the jar file. And which I kind of discovered, someone told me about this trick like a week ago, because I wanted to do this, but I didn't want to write all the scripting to build the images in locally. So with this, it just kind of does the volume mapping and just runs it in place. It does turn out that if you rebuild it, if you rebuild the jar file while the service is running, it can get kind of confused. Because it's, you're changing the world underneath its feet. Oh yeah, so that thing. Port mapping. And then this service actually depends on RabbitMQ and MongoDB. So there's this concept in Docker known as linking, which I think is useless in a production environment, but useful in a development environment. Because basically what it does is it actually does this bunch of things. It actually sets some environment variables to the host, to the IP and port, or to the, of the actual container, of the target container. and actually then adds entries into /etc hosts as well. So you can actually reference RabbitMQ or MongoDB just by their host name, and it actually knows which Docker IP address to use, which is great in development, but bad in production because you've actually hardwired what is an ephemeral IP address into the client of that particular container. So if that container service went down and you recreated the container, the clients would be pointing to the wrong place, right? But it's great for development. So then now I just use MongoDB as for the IP address, well, the host name for the database server, and RabbitMQ for the host name of the RabbitMQ server, and the linking just makes sure that it's the right Docker IP. And then here's the web app that's consuming the RESTful service, so part 2 of the file. Same kind of volume mapping trick, port mapping, and then it has a link to the other service so that it can reference it that way. And I thought this was really cool. I thought this was super helpful. Yeah, and here's the fake website. Well, the website for the app. It's sort of a fake registration page for. Yeah.
Hey Chris, so we use this thing called Cloud Foundry.
Oh, never heard of it.
One of the challenges that we have is we actually don't have enough spaces for developers to push stuff so they can be in isolation. So do you think we can generate something like this from the manifest for Cloud Foundry so they can do something locally that very carefully mimics what happens in
You know, it's funny. I cannot actually remember enough about Cloud Foundry to answer that. But yeah, that's funny. Why not have more spaces? So this UI was a little interesting because it's actually implemented using Dust.js JavaScript templating library, and it's running inside a Java 8 JVM using Nashorn. I just thought it just seemed like a good idea at the time. All right, I should let Dimitri speak. But anyway, the other thing I was just going to say, my app's sort of like that. I've got a Jenkins-based deployment pipeline that spits out Docker, that's actually builds and then tests a Docker image and then uploads it to a registry. And it uses the Docker daemon REST API to create a container, ping the health URL that Spring Boot provides, just to make sure that nothing's stupidly broken. And then it does some publishing using sort of a Docker tag command and a Docker push command. It takes about 25 seconds to do the upload. And then what's cool, sort of inception all the way down, is that Jenkins and Artifactory are themselves running as Docker containers. Which is really cool, because I actually think like the very first time I created a Jenkins Docker container, I did it on my laptop, and then I was able to push it to an EC2 instance, or push it to the registry, pull it from the registry to just move it. And then the only other thing I did is because Jenkins home and Gradle home and Artifactory home need to survive container restarts, right, or recreates. They're actually external volumes. So they're volumes that are mapped into the containers, plus they actually live on an EBS volume so that they can survive the instance going down as well. My production environment, I just have Python scripts, but one day I want to use some, I'm going to use Mesos or AWS Container Service or something when I get over my fear of all this complex clustering technology. So that's my talk. There's kind of cool stuff. And I would try, and if you're not going to use Docker for production, I would seriously recommend using it for development purposes. Docker Compose does help a lot. So thank you for listening. And I'm going to eat